For this lesson is 4.4. I can graph linear functions. So we've done functions before. Today all of our functions are going to be linear. And so first we'll talk about function tables and graphs again, and then we'll move on to story problems, and the story problems will be the really new part. So for a function table, we're going to evaluate this function in the table. You can plug in anything you want for the domain. We're going to plug in -2, -1, 0, and 1. So here I'm going to plug in -2 for x, -2 minus 3 is -5, -1 minus 3 is -4, 0 minus 3 is -3, and 1 minus 3 is -2. Then I'm going to graph those values. So when x is -2, y is -5. When x is -1, y is -4. When x is 0, y is -3. When x is 1, y is -2. And then whenever we don't have a story problem, you always connect the dots and make a line. For the next one, let's do g of x equals, let's do -3/2 x plus 1. And I'm going to plug in this time -2, 0, 2, and 4. Remember, we could plug anything in for x. So here are my function rules. So I'm going to write in -3/2 x plus 1. And then we're going to plug in each of these values for x. So -3/2 times -2 is +3. +3 plus 1 is 4. I'm going to plug in a 0. -3/2 times 0 is 0. 0 plus 1 is 1. -3/2 times 2 plus 1 is -3 plus 1 is -2. And then -3/2 times 4 plus 1. -3/2 times 4 is -6. -6, wait. Yeah. -6 plus 1 is -5. And I'll graph those ordered pairs. So when x is -2, y is +4. When x is 0, y is 1. When x is 2, y is -2. And when x is 4, y is -5. And then since it's not a story problem, we'll connect the dots and make a line. So next, let's go over for story problems when you do and do not connect the dots. So we have two kinds of data we could be talking about. We could be talking about continuous data or discrete data. So continuous data can take any value within a certain interval. Continuous data is data that can be measured, and there are no gaps in graphs representing continuous data. Let's talk about what discrete data means, and then we'll talk about examples. So discrete data can only take certain values. Discrete data is data that can be counted. There are gaps in graphs representing discrete data. So continuous data can be measured, discrete data can be counted. Let's talk about some examples. So if you're talking about how many dogs you can walk per hour, you can never walk part of a dog. You can only walk whole dogs. So that would be discrete data because we can count dogs. We don't measure dogs, we count them. And there are going to be gaps because we can't have fractions of dogs. So one example would be number of dogs walked per hour. Another example would be the number of students per class, because we can't count part of a student, so there's going to be a gap between one student and the second student. You're not going to have part of a student and have a graph where the fraction would be. Number of students per class. Or you could have like the number of books purchased because you can't buy part of a book. That would be discrete data. Continuous data doesn't have any gaps. That would be like amount of water in a glass you're filling up over time. Or if you said if you're measuring the height of a plant over time, there's not going to be any gaps because you can have fractions. My plant could be 1 inch, but it also could be 1.001 inch or 1.5 inches. There's no gaps in between data points. So let's do some examples and decide if they're continuous or discrete. So example 3 says during a clearance sale, a store is selling DVDs for $3 and CDs for $1. Graph the equation y equals 6 minus 3x to find all possible values of DVDs x and CDs y that Billy can buy with $6. Is the function continuous or discrete? Explain how you know. So it tells us the function is this. You have $6 minus the $3 that you spent on each CD. Since it's a story problem, we have to think about what values make sense for the domain and range. So the lowest number of CDs we can buy is 0. If we buy 0 CDs, we have 6 times 3 minus 0, which is 0. 6 minus 0 is 6. So if he buys 0 DVDs, then he has enough money to buy 6 CDs. He can't buy half a CD, so the next number I'm going to plug in is a 1, because none of the values in between 0 and 1 make sense. So I can do 6 times 3 minus 1, which is 3. So he buys 1 DVD, he has enough money for 3 CDs. Next I'll plug in a 2. If I plug in a 2 for x, I have 6 times 3 times 2, 6 minus 3 times 2, sorry, which is 0. I can't plug in 3 for x, because if I plug in 3, I'd get a negative value for y, which wouldn't make sense. So next, let's set up my graph. It tells me that DVDs will be my x, and CDs will be my y. And then let's just go by ones on the x and the y axis. And then let's graph these data points. So 0, 6 is my first one, 1, 3 is my second one, and then 2, 0 is my third one. We have to decide, is this continuous or discrete? Do the values in between the data points make sense? And my answer is it's going to be discrete, because can I buy half of a DVD and then buy 4.5 CDs? No, that wouldn't make sense. You can only purchase whole CDs and DVDs, so there has to be spaces in between the dots. It means we don't connect the dots and make a line. There's going to be spaces in here, or gaps. So it's discrete because you can't buy part of a CD or DVD. Okay, let's move on to the last example. The last one is example 5. A bathtub containing 25 gallons of water contains 25 gallons of water. The tub is draining at a rate of 4.5 gallons per minute. Write a function to represent the situation, then fill out the function table and graph the data. Is this function continuous or discrete? Explain how you know. So let's fill out the table first. Actually, we need to write an equation first. So y is the amount of water. We start with 25 gallons, and since it's draining, water's going out of the tub, so I'm going to subtract 4.5 gallons per minute. So we start with 25, and we're losing 4.5 gallons every minute. So that's my equation. Let's put the rule in here, 25 minus 4.5x. And we're dealing with time. I can't really have negative time, so I'm going to plug in 0 first for x. So then I have 25 minus 4.5 times 0, which is 25. Then I'll think about what I'm going to plug in next. Can I drain the tub for half a minute? I could. So I could plug in 1/2 next, or 0.5 if I want to. Then I get 25 minus 4.5 times 0.5. And then I'll simplify that. So it's going to be 22.75. And I could have plugged something else into it. I could have plugged in 1/4. I could have plugged in 1/3. All of those values would have made sense. Next, I'm going to plug in 1. 25 minus 4.5 times 1 is 20.5. And next, I could plug in 2.5 if I wanted. I could plug in 2.1. I could plug in 1.1. I'm just going to plug in 2. You could plug in any value you really wanted. That's positive. 4.5 times 2 is 9. 25 minus 9 is 16. So now I have some data points that I can graph. I'm going to measure time on my x-axis in minutes, and the water in the bathtub is on the y in gallons. And then I'm going to graph my data points. So on my x-axis, it'll work to go by, I'm going to go by 1/2. So I'm going to make every 2 spaces be 1. And on my y-axis, I'm going to go by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45. So at 0 minutes, there are 25 gallons in the tank, or in the tub, sorry. At half a minute, there are 22.75, so about here. At 1 minute, there's 20.5, so a little above the 20. And at 2 minutes, there are 16 gallons in the tub, so right above the 15. And then I have to think, is it continuous or discrete? It's continuous because any value would make sense. Sorry, my writing is not turning out so good. Because any value within the range, within the interval of time has to be positive and before we run out of water. But any value in the interval would make sense. So it's going to be continuous, which means I want to connect the dots because any value in this range is going to make sense. I could check the water level at 2.1 minutes, or I could check at 1.5 minutes, or I could check at 3.77 minutes. Since all of those values in between make sense, I want to make my line because all of those values make sense in the problem.